Hello friends, this is Durga again from ITversity, a one-stop shop to learn all the technologies. At this time we were talking about Cloudera certified administrator of Apache Hadoop, and as part of HDFS category, we are going to talk about learning object to describe file read and write paths. Before getting into the details about file read and write paths, let us understand how a file will be stored in HDFS. As I have explained earlier as well, depending upon the size of the file and the block size, the file will be divided into multiple blocks. In this case, if the block size is 128 MB and if the file size is less than or equal to 256 MB, the file will be divided into two blocks. And for the failover, transparent failover and reliability purpose, we have the concept of replication factor, and based upon the replication factor, each block will have multiple copies. By default it is 3. In this case each block is cloned into 2 copies with replication factor 2. That's why you can say that a file called /tmp/file1.txt is actually divided into 2 blocks, block A and block B, and each block have 2 copies. Block A is on data node 2 and data node 3, data node 2 and data node 3, and block B is on data node 1 and data node 3. So this is how a file will be divided into blocks and cloned into multiple copies depending upon the replication factor. And typically we try to copy the files from the client by running commands such as Hadoop fs -put or copy from local, the way we have done earlier. We will come back to those commands again later. There is a complete learning task which covers those things, and I will explain at that time. But for now, just remember that a file will be divided into multiple blocks, and each block will have multiple copies depending upon the replication factor. So also we need to understand, given a size of a file, how many blocks the file will be divided into, and what will be the size of the each block. In this case, I am taking the case of a file by name f1 of 400 MB with block size 128 MB. Then the file will be divided into 4 blocks, because 400 divided by 128 equal to 3 point something, so it will always be sealed. So the leftover will be the last block. So in this case, the file will be divided into 4 blocks, 3 128 MB, which means that 384 MB in 3 blocks, and the leftover 16 MB will go into the 4th block. So this is how the file will be divided. And actually, when you try copying the file into HDFS, you can actually read it while the file is being written, because the file will be copied in proper order, starting from first block till the last block. Hence, you will be able to read the file while the file is being written into HDFS. Also, to ensure the data integrity of the file, HDFS uses checksum to validate both reads and writes at each block level. Checksums are stored along with the blocks. So if you log into the cluster, in this case I have logged into one of the data nodes, and as you are aware, if you follow my videos, the data node data directory is dfsdn. You can also confirm going to configuration files, HDFS configuration. In our setup, we have only one data node data directory, but in actual production cluster, you will have multiple data node data directories for each mount point. Okay, data node dot data dot dir, and you can see there is only one location, and the locations will be consistent across all the data nodes. And in this case, the location is dfsdn. You can go to any of the node in the cluster, and if you run this command called find dot, it's a Linux command. We are trying to search for all the files under this data node data directory, and you can see that for each block, for example, let's say this is the block ID. Okay, so find name and hit enter. You can see that there is a file with name blk underscore block id, and there is another file blk underscore block id underscore some number dot meta. So this meta file will have details such as checksum, which will ensure the data integrity. So based on the block, the checksum will be computed and will be stored in metadata in meta file, and when the file is written for each block, the checksum will be computed on the client. So if you go back to this slide, so this is a node from where we have run the Hadoop FS command, Hadoop FS -put command to copy the file, and the file will be divided into blocks like this, and for each block the client will compute the checksum. And when the file is when the block is copied onto the data node 2, data node 3, or for block B, data node 1 and data node 3, on the corresponding node for the corresponding block, the checksum will be computed, and once the block is copied, the checksum will be sent back to the client, and the client will compare the checksum which is computed on the client location and which is computed on the data node on which data block is copied. If both the checksums are equal or same, then the block is copied correctly without any corruption while transferring the file from the client node to the HDFS. So that's how at the time of write the checksum will be computed, and even at the time of read same thing will happen. Already you have the checksum on the already you have the checksum saved on the target along with the block on the data node along with the block, and when the block is read along with the block, you will also get the checksum, and also when the block is being read on the client, the checksum will be computed at the time of the read, and the checksum which is generated at the time of the read on client will be compared with the checksum which we got from the corresponding data node, and if both are equal, then the read is successful without any issues. Otherwise it will log as if there is an issue. Okay, so all these details about whether the read or write is successful or not by comparing checksums will be persistently stored in logs, and these details will assist us in identifying the bad disks. Typically the checksums will differ only if there are some issues with the bad disks which result in corruption of the data, or sometimes it could be due to the network copy. So those kind of issues will be easily identified by persistently storing the details whether the read and writes are successful by comparing the checksums. Now we will talk about how the read and write happens. So for that there is a concept of anatomy of a file read and anatomy of file write, which means that understanding the internals of how the file will be read and file will be write. So on the client node from which we submit Hadoop FS, copy from local, or copy to local, or put or get commands, depending upon the type of the command, it will result in read or write. So read means trying to read the data from HDFS using -cat command or -get command, etc. And write means writing into HDFS by using -put command or -copy from local command. So first we will talk about read, which means that using -cat command or -copy to local or -get command. So all these commands result in read the data from HDFS. So when the client issues the command such as Hadoop FS -cat or -copy to local or -get, what first thing which will happen is it will invoke a class called distributed file system, and then it will get the block locations of the file. So each file will have the block locations, and hence the distributed file system have the API to get the block locations. Once the block locations are retrieved, which means that we will identify what are the blocks associated with that file and what are the data nodes on which the files exists. So here, once you get the block locations, it will issue the read through a class called fs data input stream, and it will go and read starting from block 1 till the block till the last block in sequential order. So first it will so let's say there are two blocks, one on this data node, the first one on this data node and the second one on this data node. Hence it will actually read the blocks in sequential order, and once the read is successful, it will actually close the JVM which initiate this read when you issue the command such as Hadoop fs -cat or copy to local or get command. So you can get into the details here. The same thing which I have explained is written in theory. You can see it here. Data is streamed from the data node back to the client, which calls read repeatedly on the stream. Step 4, when the end of the block is reached, DFS input stream will close the connection to the data node, then find the best data node for the next block. This happens transparently to the client, which from its point of view is just reading a continuous stream. Okay, blocks are read in order. So it is very important that to understand that the blocks will be read in order. It will not be read in parallel when you issue commands such as Hadoop fs -get or -copy to local or -cat command, because you have to read the data the way the data is stored in the original file. If the read happens in parallel, then it doesn't look good. But when you actually issue Hadoop jar command, it's a different story. We are talking about reading the data, not processing the data. So reading the data is done by commands such as Hadoop fs -cat, which will actually read the data from HDFS and print on standard out, or copy to local, which copy from HDFS into the local file system, or get, which does the same thing. As we have gone through the anatomy of file read, now we will go through anatomy of file write. So in this case, what will happen is, first the HDFS client will go through distributed file system and go to the name node, and it will determine which data nodes the blocks have to be stored. Okay, and then it will issue the write using fs data output stream. For read it is fs data input stream, for write it is fs data output stream. And each block will have multiple copies depending upon replication factor. By default it is 3, so by default there will be 3 copies. So the write actually makes sure the block is written from client to one of the data nodes, which will issue the write packet. And as the data is being written to, as the data for a given block is written to the first data node or master data node for that block, once the buffer is flushed into HDFS, once the file is written, the data node will establish connection to other data nodes to copy the same block onto the next data node. And while the next data node get the copy of the block which the first data node received from the client, it will establish a connection to another data node to copy the to have the third copy on a third different data node. So as client only writes to one data node, and that data node makes sure that the block is written to another data node, and the second data node makes sure that the block is written to the next data node. As it is happening in the pipe fashion, it is called piped write. So each block will be written in piped fashion, and writes typically happen in parallel. So if there are two blocks that needs to be copied, so the client can actually copy multiple blocks in parallel. While reading, it only reads in stream and serial fashion. While write, it can actually write in parallel. So this is what it is written here. So as the client writes data, DFS output stream splits it into packets which it writes to an internal queue called the data queue. The data queue is consumed by the data streamer, which is responsible for asking the name node to allocate new blocks by picking a list of suitable data nodes to store the replicas. The list of data nodes forms a pipeline, and here we will assume the replication level is 3, so there are 3 nodes in the pipeline. The data streamer streams the packets to the first data node in the pipeline, which stores the packet and forwards it to the second data node in the pipeline. Similarly, second data node stores the packet and forward it to the third data node in the pipeline. DFS output stream also maintains an internal queue of packets that are waiting to be acknowledged by the data nodes called the ACK queue. A packet is removed from the ACK queue only when it has been acknowledged by all the data nodes in the pipeline. Here you can see that once the write is issued, once the block is completely copied onto the final data node, we will receive the acknowledgement packet in the reverse order, and finally the first data node will acknowledge to the FS data output stream, which will confirm that the block is copied successfully. If a node fails while data is being written to it, then the following actions are taken, which is transparent to client writing the data. First, the pipeline is closed. So for example, let's say if the write to the third data node is failed, in that case what will happen is the data node will actually try to recopy the block from the beginning to some other data node. If when the client is trying to write to the first data node and the write to first data node itself fails, then it will completely discard the pipeline and it will initiate a new pipeline transparently without showing any issues to the client. So that is what it is explained here. First, the pipeline is closed and any packets in the acknowledged queue are added to the front of the data queue, so that data nodes that are downstream from the fail node will not miss any packets. So this is the first case where if the second data node or third data node are failed. And the failed data node is removed from the pipeline, and the remainder of the block data is returned to the 2 good data nodes in the pipeline. The name node notices that the block is under replicated and it arranges for a further replica to be created on another node. Subsequent blocks are then treated as normal. Okay, it's possible but unlikely that multiple data nodes fail while a block is being written. As long as dfs.replication.min are written, the write will succeed and the block will be asynchronously replicated across the cluster until its target replication factor is reached. When the client has finished writing the data, it calls close on the stream. The action flushes all the remaining packets to the data node pipeline and waits for acknowledgements before contacting the name node to signal that the file is complete. The name node already knows which blocks the file is made up of, so it only has to wait for blocks to be minimally replicated before writing successfully. So that is about anatomy of file read and anatomy of file write. Okay, here you need to remember few important things. So I made a mistake by saying that the write happens in parallel. It need not be true actually. The writes also have to be done in serial fashion. The reason is, if you go back, we said that HDFS permits to read a file that is being written. So if you have 1 terabyte file, when you try to copy that 1 terabyte file, it will take few minutes. After a minute, if you try to read the file, it will try to read it without any issues, while the rest of the remaining stuff is being written. And this will work only if both the read and write is serial. If write is parallel, then reading the file might not be feasible. So I am incorrect when I say that the writes are parallel. Both are actually streamed. Commands such as copy from local, copy to local, get, put, which results in read or write, both will be done in serial fashion. Okay, and another important thing you need to understand is the writes will be done using pipeline. So when you actually try to write a file into HDFS, each block will be copied in the form of pipeline. A client will only write to one of the data nodes, and that data node will take care of writing it to the second data node, and the second data node will try to write it to the third data node, and it will go on until the replication factor reaches. In this case, if the replication factor is 3, and the pipeline will be 3 level. If the replication factor is 5, pipeline is 5 level. Okay, and you also need to understand another important parameter called DFS.replication.min. So when you actually the relevance of that parameter DFS.replication.min is that if you say DFS replication.min as the 2 and replication factor is 3, the write of each block is only considered to be successful if there are at least 2 copies of each of the block. So minimum, always the minimum replication factor has to be satisfied to consider your write as successful. If the minimum replication factor is not satisfied, then it will fail, saying that the write is not successful. Okay, if it is 1, even if 1 copy of each block is there, then the write is treated as successful for that file. But over time, if the replication factor is 3 and if the minimum replication factor is 1, it will be reported as under replicated, and it will eventually catch up by running balancer. You will see multiple copies of each of the blocks satisfying the replication factor. So all these concepts are very important, and also make sure you understand that the files are written and read in serial fashion, and also make sure you remember that you can actually read the file while the file is being written, and also you should remember that what the relevance of the checksum, and also how a file will be divided into multiple blocks based on the block size. Especially all the blocks will be evenly distributed except for the last one. Last one will have the leftover of the file size. So if the file size is 400 MB, there will be 4 blocks. If the block size is 128 MB, and then there will be 3 blocks of size 128 MB and 1 block of 16 MB. If the file size is 200 MB and if the block size is 128 MB, the file will be divided into 2 blocks. The first one will be 128 MB and the next one will be 72 MB. Never the files will be divided evenly, or the last one will occupy the complete block size. It all depends upon the leftover size of the final block. Okay, so that being said, we have covered how about describing file read and write paths in detail. And if you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss further about certifications or big data, please join my LinkedIn group called ITversity-certifications or ITversity-big data. And if you want to support me, please go to my channel, and on top of the right, when you go to my channel, youtube.com/itversityin, on the top right corner of this channel under subscribe button, you will see support the channel section. You can click on that and you can contribute any amount between $1 to $500. So if you want to support me to upload more and more content like this over time, please click on that and support. And finally, if you are not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time, not just Hadoop, but vast area of IT technologies. That being said, thank you, bye.